In this video, we're going to go over key features of the absolute value graph. So if you picked up a copy of the guided notes, you'll want to be looking for the one that's labeled absolute value graphing and key features. So you will need a paper if you don't have the notes, and you will need a pencil for this. So before we begin, I just want to remind us of a couple things. The first is that domain. Remember, that's your x values. That's how far left and right your graph moves. The range, remember, that's your y values. That's up and down. That's how far down and how high up your graph goes. The open, remember, open is represented by an open circle. So it looks like that. Or we use parentheses to show open. Closed, remember, that's represented by a closed circle, so a circle that's filled in, and then brackets. So this is all stuff that we saw with the linear unit. We're just going to see it here again with the absolute value unit. The last thing I want to remind you of is the way we determine if a graph represents a function or not. And remember, with linear, the way we did this was we used the vertical line test. So a graph is a function if any vertical line touches the graph in exactly one point. So remember, these are what vertical lines look like. So they're straight up and down. So it says if I draw any vertical line through my function, does each of those vertical lines touch the graph at exactly one point? If the answer there is yes, then we have a function. So let's look at our first example. So you'll want to pause the video to sketch this graph. And then we're going to analyze it using seven steps. So in my graph, the x-axis I'm highlighting in yellow. So this is my x. The y-axis, I'll highlight that in green. So here's my y. So these are my two axes, the x-axis and the y-axis. So the first question we're going to look at, so the graph I'm given is this one right here that I'm highlighting in purple. Now, remember, we don't always show the end arrows, but it's going to be implied that this graph continues on forever in both directions. So the first question, does the graph represent a function? So remember, we're just going to draw a couple vertical lines to see, do each of those vertical lines touch my function exactly once? So I'm going to draw a couple vertical lines. Let's say we draw this one. Well, this one touches in exactly one spot. So we draw another one. This one touches in exactly one spot. And for this graph, if we drew one more, it would touch exactly one spot right there. So all three of those vertical lines touch the graph in exactly one spot. So here, yes, this is a function. So we're going to say yes for that one. The next part, domain. We should be familiar with domain. We saw this with linear. There's no restriction on what my x could be because the end arrows tell me it goes on forever. So since this is a function, I know that my domain here is all real numbers because both ends of the graph continue on forever. So the domain, all real numbers. Remember, we say negative infinity to infinity. So the whole x-axis. The range, this one's special. So remember, range is smallest y, largest y. So if I look on my y-axis, so I'm going to erase some of my blue lines that I drew here. If I look at the y-axis that I have highlighted there in green, and I want you to notice that this purple graph starts up at this point that I'm highlighting it here in purple. So this is the highest point on my graph. So that means this is the ordered pair 0, 0. So the y value there is 0, because remember it's x comma y. So this is the highest point on my graph. If you'll notice, all the other points on this purple line lie below that ordered pair 0, 0. So that means my highest y value is 0. So I'm going to write 0. And that means my smallest y value is all the way down here. We would keep on going down forever. Remember, down forever is how we say negative infinity. So my range is negative infinity to 0. Negative infinity gets a parenthesis, 0 gets a bracket because it's a closed circle. So for the x and y-intercepts, this one's sort of a special case. The x and y-intercepts, those are both at the origin. So this is the ordered pair 0, 0, and that's both an x-intercept and a y-intercept. So 0, 0 is both an x-intercept and a y-intercept. End behavior. So we learned first about this in the last unit when we looked at linear. Remember, end behavior is asking you, as x approaches negative infinity, what happens to y? So remember, negative infinity, this is like you're looking at the left arrow of the graph. So if I look at my graph, the left arrow is pointing down. So this is negative infinity. So as x approaches negative infinity, y approaches negative infinity. And then, let me just give myself a little bit more room. And then for the other part, so there's another piece of this, as x approaches positive infinity, meaning as your x's get bigger. So here's negative infinity on the x, and here's positive infinity on the x. As x approaches positive infinity, what's happening to y? So if I look, again, this is just saying, look at the right arrow of your graph. Which way is that pointing? So if I look at my graph, the right arrow is pointing down. So that means as x approaches positive infinity, y approaches negative infinity. Remember, the vertex has that special point that I mentioned when we were talking about range. That's this point up here that I'm putting a green dot on. That's the vertex. I'm going to label that. I'm going to write vertex here for us to see. So the vertex is this ordered pair 0, 0. This vertex is where, if you can kind of tell, there's two pieces to the graph. There's this first piece, I'm going to label this one number 1, and the second piece here, I'm going to label it number 2. That's where those two pieces of the graph meet. So that's the vertex. This vertex, going on to question number 7, is the highest point on the graph. It's what we call a maximum, because there's no other point that's larger than the vertex. So for absolute values, your vertex will either be a highest point or a lowest point. It would be a max or a min. In this case, your vertex is a maximum. It's the highest point. We'll go ahead and go through another example similar to this one. So we'll answer these same 7 questions in this next example. So this would be example 2. So sketch the graph. Again, you're going to want to start off by creating your x and y axis. So here's the y-axis. This time I'm highlighting the y-axis in yellow. And then here's the x-axis. This time I'm highlighting the x-axis in green. So here's the x-axis. So and then the function that they gave us, I'll highlight it in red. So this is the function that we're considering for this problem. So the question says, does the graph represent a function? Well, if you notice, again, on the left side of the graph and on the right side, the 2 arrows that I just drew, those go on forever in both directions. So does the graph represent a function? So if I draw a couple vertical lines through my graph, so let's say we draw this one, it's not a very good vertical line. If we drew this one, if we draw this one, let's just draw one more. So if we draw this one, all of those touch the graph in exactly one spot. So I know that this is a function. So for that one, I can write, yes, it's a function because it passes the vertical line test. Number 2, the domain. So as I mentioned when we were talking about is it a function or not, we can see that it goes forever in both directions, to the left and to the right. There's no restriction on what I could plug in for x. I could plug any value in for x because this is a solid line that continues forever in both directions, both the left side and on the right side. So it goes from negative infinity to infinity. There is no restriction on the domain. It's all real numbers. I can plug any number in for x. The range, remember, just like the domain, smallest x to largest x, the range is smallest y to largest y. So I'm going to look on my graph, and I want you to notice this special point right here that we talked about in the first example. Remember, we called that the vertex. This vertex has an ordered pair of an x value of 2 and a y value of 0. So remember, it's x comma y. This point, this vertex is a lowest point on the graph. There is no point that goes below the vertex. So this point that we are defining as 2 comma 0, this is the lowest point on the graph. There's no point that's below this point. All the other points are larger than that. So that means this is the smallest point. So it's 0. The y value is 0. And it goes all the way up. So all the other y values are larger. So 0, here's 1, 2, 3. All these y values keep going up from 0. So we call that all the way up to infinity. Remember, 0 is going to get a bracket because it's included. That was a closed circle. And then infinity always gets a parenthesis. For the x-intercept, remember x-intercept, you're looking at where does the graph cross the x-axis. So, so I highlighted the x-axis in green. Notice the graph crosses the x-axis right at the vertex. It crosses right here. This is your x-intercept. This is the point 2 comma 0. So the x-intercept is 2, 0. The next one is the y-intercept. So that's where the graph crosses the y-axis. So here's the y-axis is what I highlighted in yellow. So I'm going to put, where does this red line touch the yellow line? Well, it touches right here. So this is the point 0, 1, 2. So this is the point 0, comma 2. So my y-intercept is the ordered pair 0, comma 2. So this is my x-intercept, 2, 0, and my y-intercept is 0, 2. So it just happens that the x-intercept and y-intercept both have a 2 in them. It won't necessarily always be the case that they have the same value or a similar value. So the x-intercept is 2, 0, the y-intercept is 0, 2. The end behavior. So for this graph, remember the end behavior, there's 2 pieces to end behavior. You're looking at what's happening to the right and what's happening to the left. So let me erase some of this when I answer that question. Okay, so for end behavior, remember you're looking at as x approaches negative infinity, what happens to y? And then as x approaches positive infinity, what's happening to y? So remember, negative infinity is just like asking what's happening to the left side of your graph. So what's happening to the left arrow? So if you notice, my left arrow is pointing upwards. So that is positive infinity because it's pointing up. The right arrow, so I'm going to write positive infinity there. The right arrow is also pointing up, so it's up, and that's also positive infinity because it's up. So as x approaches positive infinity, y approaches infinity. So what I want you to know is for absolute value, when you do end behavior, your y's are always going to approach the same infinity. They'll either both be positive or they'll both be negative. In this case, they're both pointing up, so they're both positive. Whereas with linear, we had one of each. One was positive and one was negative. Question 6, what is the vertex? So remember, that was that special point. That was where each of those 2 lines met. So remember, so in this example, this is one line that I'm highlighting in blue. And then another line, the other line I'm highlighting in purple. So this is the other line. So there's 2 lines. Both of those lines meet at that green or that purple dot that I'm filling in. That is the vertex. So it's where both parts of your graph meet. This has the ordered pair 2, 0. So this is the vertex. That's where each of those lines meet up together. That's what forms that V. So the vertex is 2, 0. And we already sort of mentioned it with the range. This point is the lowest point on the graph, this vertex. There's no point that goes below the ordered pair 2, 0. All the other points are larger than 2, 0. So the vertex in this example is a minimum because there's no other point that's larger than the point 2, 0. There's an assignment in MathXL for you to start on. You should be able to get a good way through that assignment. There's a couple problems that you won't be able to do just yet. And we'll go over those types of problems in our next meet.